Hi everyone, this is Karthika, Faculty of Physics, working in SNS College of Engineering. So in this lecture series, I am going to discuss about the topics in laser which comes under the photonics. Here the lecture contents are what is called photonics and acronym for laser, invention of laser and then principle of laser. So in this principle we are going to discuss about the stimulated emission. Next one is the photonics. So before that we know that the current can be amplified by the vacuum tube or transistor amplifier. So similarly the light also can be amplified and that is termed as the laser. So that laser comes under the photonics. So photonics comes from the word called photon, that is nothing but the light particles. Photon is a light particle. Photonics is the science and technology of generating, controlling and detecting the photons, which are the particles of light. Laser. So we know that laser is a light source. So that all we know about the laser light, but that is a device that generate light by a process called stimulated emission. Here the word stimulated emission is highlighted. So that is the working principle of laser light. Acronym. So acronym for laser is light amplification by stimulated emission of radiation. So from this only we are taking the first letters and that is formed by the laser. So that is termed as laser. So laser is light amplification by stimulated emission of radiation. So next is the who invented the laser. So this picture, this scientist name is T.H. Mayman. So in 1960 only he found the first solid laser called ruby laser. So ruby laser that indicates that emits the red light, and that is the first solid laser. So after the discovery of that first laser, that leads to many type of lasers cause due to the lasing action that with atoms or ions or with the molecules in gas, solid and liquids. So nowadays we are having a different types of laser using the different materials, that might be the gas or that might be the liquid or that might be the different solid. So first he used the solid that is called the ruby laser. So this is the first ruby laser in 1960. So it will have nearly the frequency 10 power 14 hertz. So that leads to many applications in the scientific world, and like that is in industrial applications we have, and medical applications also we have. So because of the frequency range. So the important thing, that is the principle of laser. So the principle here is stimulated emission. Stimulated means one atom will trigger the another atom. So here the incident photon will trigger the excited atom to make the transition to the ground state. So that generated photon also will be identical to the triggering photon. So with respect to frequency, phase and propagation direction. So both the incident photon and the emitted photon will have the same frequency, phase, propagation direction. So this is the diagram for stimulated emission. So for the emission process, at least we need two energy levels. So we have two energy levels, E1 and E2. So the E1 is in the ground state, so ground energy level or ground state, and E2 is the excited state. So in stimulated emission process, the photons will be in the excited state, that should be induced or stimulated with the help of the incident photon. So from the excited state, that photon will come to the ground state by emitting the another photon. So in output we will have a multiple number of photons. So this is the process. So the multiplication of photons through stimulated emissions leads to coherent, powerful, monochromatic, collimated beam of light. So this light is known as a laser light. So we'll continue in the next session. Thank you.